whole idea of handwriting recognition was just such an interesting thing. So I decided to take it upon myself to tweak the program just a bit. I'll show you what I tweaked, and then we'll run through the code so that way I can explain what's really going on in it. So what we have here is we got just some letters I wrote, and the best part is, they're different sizes, they're not all perfect for the program, I just took these screenshots. They're not in the black and white that's really necessary. So when I run the pre-processing code, okay, so we got new files. So these are the original files, like just keep them. But look at this now. You can see that they're now black on or white on black background instead of black on white. So I'm just gonna, replace all the files in there. And so that's the first step. So this is the pre-processing code. So I learned how to basically, import OS means that it's just gonna run through the directory. So this is the path to it, the folder that I am at. Then it does a for loop. So if the file name ends in a PNG, so it's just identifying its pictures. If I had like a text document in it, obviously we don't want to mess with that. So that's what we got here. So now it's open, and we're calling it F. I was just printing it when I was testing it. This is print outputs. So now with this image open F, this is the directory and then the file name. We're running through the files in the directory. I'm also adding the directory just to make sure. So with it open, we set our first variable to resize because the EMNIST neural net, it wants it at 128 pixels, right? Let me save it. Then I imported this is called Pillow. And what Pillow is doing here is that it is actually inverting the image. That's basically what's going on, because what's opposite of black on white? White on black. That's what you're getting. So then we just saved it, and that all happened. So now, what do we have here? This is what we were going through in the whole tutorial. So first thing we're doing is importing the EMNIST data. I am getting it from GitHub. So this is just testing it, because if the from and the import statement doesn't work, then the rest of the program is just bogus. So we are just testing that the EMNIST libraries are coming in. Then what's coming here? We're extracting them. These are the letters that we need to get, and we're just trying to make sure that all the pixels are between 0 and 1. Dividing by 255 is actually how many RGB values can you have? They're from 0 to 255. So when you divide this is just checking that, okay, if it's 256, that's not an RGB value. So that's above 1. Thus, we have this whole this statement here. We're just confirming. So next, what are we doing? We're just testing 60,000 instances. That's how much data is in the EMNIST. It's just so much data. So we're just extracting all the samples, testing data sets, right? So what is matplotlib pyplot as PLT? So this as PLT, when I do the PLT, this is like one thing that I added was that you're able to, because in PyCharm, unlike in the Google notebook, I'm not able to just display it. I have to actually explicitly say that I want it to be shown. So we'll start running through the code now. All right, so imported EMNIST for that we needed. Exactly. Okay, wow, look at that. That's the letter M. Okay, so now if I wanted to change it, I could definitely change it in this here. This is where I would start changing the values, depending on the letter. Now, the rest of the program is running. I could stop it. I need to keep stop. Okay, so I stopped it. So now, what if I wanted to change it? Okay, so why don't we change it to 54? I don't actually even know what it's going to be, but we're going to see. Okay. Doing its thing. Okay, still. So image label is C. Looks like I have to change one more thing before I'm able to show that it's a letter C. Okay, it's this. So I don't know exactly what's going on. 14,000. I'm assuming what letter is M, A, B, C, D, E, F, G, H, I, J, K, L, M. What is M? 14th letter in the alphabet. So why don't we try 2000? So that way we can get to C, because I did write C there with that 54. So let's see what's going to happen now. A J, okay, so it's just random letters. I'm not really sure how it's going by in terms of that, but that's not relevant. This is just showing you like what are things that I can change. I can change the image index. If I wanted to add an input, I can easily do that. But anyways, so now what's happening in step 2? Now we're making the machine. This is what is sklearn? sklearn is one of the, there's another one called TensorFlow. sklearn is another kind of these machine learning thingies. So this is the classifier here. So I wanted to run it a little faster than usual. So that way, I'm just going to do it at 5 iterations because I don't really want to like run it for that many times. Like, sure, it'll be more accurate, right? But I for the purpose of this video, I'm just trying to get the assignment done. So I'm just going to run through it really quickly. So, okay, look at the console now. We're at our 2nd iteration, 3rd iteration, 4th iteration, 5th. Okay, now what is this? This is called the what? The error of loss function. So this is basically telling us, so this line here is our values, our predicted values, the correct ones. And these are when they're predicted to be incorrectly. So in a good error of loss function, I want these losses to be going down gradually, which is what's going on here actually in our first at least network. So why don't we run it a couple times? Now, what is this? This is one of, what is this? This is letter number 3. This is the L. This is the L that's being outputted. Or no, this is when it's the letter I is being predicted to be L. Because think about it. When you have a letter L, it looks just like an I. So we don't want that to really be happening. So what is it saying? In the machine, the data set, it tells you, we already know they're labeled. So that's why it knows 80 times letter I was predicted to be L. So, let me just show you exactly where I'm looking at right now. So predicted letter L, actual letter is I. So what other letters look the same? You know, letter O and letter A. So when is an O, or when is an A being predicted to be an O? Why don't we find out? I'm just going to run it again. And we're going to see what. So we got the J, that's from before. That's that index 3000, just random letters, you know. In fact, it's telling me that that's actually an add, believe it or not. It's kind of weird. Oh, that's because they weren't the same. So, couldn't show mistake number 5 because there are only 4 mistakes to be shown. So, this is actually not a very common problem, believe it or not. But I thought that the letter A was actually pretty similar to letter O. It's more similar to the letter U, to be honest with you. So now, what are we doing here? This is the second running of the, this is the classifier. So we're running it 10 times. I'm just shortening it so I can get this assignment done on time. So we're just training it. What's it going to say? Okay, what is this? This is the L from my data set. Notice how it's just like, it's very similar to the EMNIST data, believe it or not. This is the scanned image that I made. So now, what is going to happen here is we have a file, a variable now. Variable is called files. So we have the variable called files. What is files now? It is an array. What array of what? Array of all the, or a list, to be honest. I think it's a list, or list array. I'm pretty sure they're interchangeable. So what's going on? OS walk. It's walking through all the files in this directory. Each one of these are in the list. This is the list index. Reading it as a grayscale. It's just reading the image. And then this loop, this for I in range, I is the index in the range of the length of files. What is length of files? How many values are in this list here. So range then tells us numerical answer. The range is setting that. The length is telling us the numerical. So then range, because it could be like just from 10, but I don't have 10 filed in this folder. I only have 9, or I have 9 or 11. So now the append, you're appending what? Image, this is variable here, into this array that I now have. New arrays called handwritten story. So now it's making it into a sentence. All these separate, it's combining into one. Imports them. Imported scanned images. That's what's going on here. I can even print out what values are being listed in the array if I really wanted to, not necessarily for right now, because I'm just trying to get the assignment done before 11:59. So now, PLT show, obviously we're talking about PyPlot, just show, this is the show function. So letter 11, index 4. What is index 4? 0, 1, or 1, 2, 3, 4. This is that L that we're talking about. If I wanted to change it to 5, then we're going to be showing the O from before. So now what's going on here? Process story. This is when it's giving it the blur that why is there that blur? The blur is that it gives you the better range and a broad definition of what the letter is, because there's sometimes that variance. This is the blur is accounting for the variance that's going to happen. That's why we add this blur filter. And at the end, we are going to be processing it, and it will say, "Hello world, this is hello Ahmad." That's what's going to say at the end, because it should process the scanned images. I do want it to print out the actual process story. So what am I going to do? I'm actually going to, I don't think I have the print for that. I don't see it. So I'm just going to print process story just so it'll actually say the process story. Okay. And why don't we run this one last time, and we should be good for business. This is a broad overview of how this neural network, the classifier, error of loss functions, it's just all of this is all combined to make a really good thing. Hopefully this file isn't too big, to be honest with you, because my computer is very, very low on space, but hopefully we're running, we're going to run this show on the road. So this is good. The loss is decreasing as we are running more more iterations of the program. We're going up to 10 just because I'm just trying to get this, trying to squeeze it all through in a bite-sized form. Otherwise, I'd have to speed it up, and there would be no space. Just a really accurate one's going to really. Oh, what is the O? Remember we were talking about 1, 2, 3, 4, 5. That's the O. So this is actually the arrays printing out. And, okay, I have to tweak the program just a bit, but then it will show the actual story. So let me just exit here, and I'll send a screenshot when it's done. How do I end this screen recording?